Welcome to our Friday V0 maintenance slash repair session. So, let me quickly get started here. Perfect. Everything seems to be working today. That's very unexpected. Let's see if this stays true for the rest of the stream, but so far it looks good. Well, so last time we were working on the little V0 here. And a couple of things we did. I mean, mostly the LDs. Um, and before Christmas, we were also working on the rails. Left and right here. We had, let me remember. Yeah, we did the lightweight X-axis here. And we also like greased the rails before Christmas and everything. And I also noticed that like in the front area here on the bed, like I have a little bit of like issues with the bed level. It's very odd where like it's fine on all other three corners, just in this area it's not okay for some reason. Um, so yeah, that's something we need to fix. I am still not sure what the issue there is. But what I know, and that's the one thing I want to start with first, and also something we discussed last stream, is here on this XY joint, you see, maybe if I do it right, that there is a crack here. And I'm not quite sure when this crack formed, but yeah, that's definitely not good. And I have a suspicion that this is not very helpful. So what we discussed last time is, I mean, technically I could have reprinted the part and we just, yeah, me and my camera having a little bit of issues, as always. Um, I thought I fixed this. 1 second. Okay, well, I shouldn't have said that I don't have technical issues today. Okay, well, here we go. So basically it's something we discussed last stream, and technically I could have just replaced the part and would have been fine. But I think it's also a good opportunity to just swap in these. That's basically the same part that we have here, but it's machined from aluminum, so it's like more stiff, higher quality, nicer part. And we did actually something similar on the switch wire, where we swapped out the X-axis carriage with the CNC part, which actually is really cool because like I had two of them fail for some reason. Um, so yeah, I think that's just a good opportunity to do the same here. Hi, the Ravenkeeper. Good evening. They arrived in time, as you can see. Yeah, so let's swap out these. Then definitely the crack is gone, and I think it's also like more future-proof solution than like just replacing a print part. And yeah, I think let's just get started. There's not much to say. I think the first thing we definitely need to do is just to remove all the panels that we have proper access. We also need to remove the tool head for sure. So if you remove the tool head, maybe we can just place the tool head on the head here. But I think we also at least need to like loosen one of the corner pieces here, because we need to remove the tension from the belts. And that's best done by just removing these two parts here. What means in turn that we also have to remove this top extrusion here. So that's a couple of things we need to take apart. So let's get started. And I'm missing my little bucket where I put all the stuff in. I actually don't know where I put that. Okay, let's just use this for now. Just that we collect all the screws we remove in one place. And so often, I take these like off so often that I definitely need to like invest into the clipped panel holder soon. There we go. And this is the first panel. Okay. Try to a bit further up. Yeah, there's this one screw connection here. I definitely have to make this more stable. Because I added, like, since last year, I added this extension part here. So I now have more reach, but now the weight is quite high. I need to find a better solution. Maybe we can 3D print something there and like create our custom extension arm. Hi there, Steve. Let's put these over here for now. Oh, well. I guess we have the next panel loose. Let's see if we can just keep the head here. So my idea would just be to like remove the screws of the tool head and then just place it here. Because I really hate removing this cable. So if I don't absolutely have to, I prefer not to. I wonder, did we actually ever switch in the honey badger fans in here? Because there was something I thought about doing at some point. But I think the honey badger fans are still with the poor man's printer. Oh, here we go. No, it's still the LDO fans. Okay, let's see if we can just like put this here and work on the rest of the printer without dropping that. Okay, so to remove the XY joints, we have to remove these 4 screws here on both sides, and then we also, I mean, technically, if we remove these 4 screws, we can twist this out. Like the XY joint goes a little bit under the extrusion here, so we can lift it out, but maybe we can like twist it out and remove it that way, like once it's not attached here anymore. But to do that, we definitely need to remove the tension on the belts. And to do that, we need to remove the front part, and to do that, we need to remove that. So yeah, I think we need to take a lot of stuff apart. So let's just get the cam idlers out. Yeah, here we go. I'm not a fan of these cam locks. I don't know, like I don't use them. They're like always painful to get out. Okay, let's see. So if we remove this one here. Let's try to keep all the panel stuff on one side. Um, So then this is now somewhat loose. Oh, yeah, it's also removed the Nevermore here. But I guess we also need to remove that panel clip here. Okay. So this is loose here. Ah, but then we have to remove the head here. Otherwise I cannot remove the screw that holds this one place here. Just hang this here. Yeah, exactly. Now there's a hidden screw here. But let's just remove the head altogether. Then it's out of the way. And then maybe we can do something crazy and just remove the filament as well. Yeah, this is now also loose. Oh, by the way, like I was talking about this last stream, and I think here you can see it really well. You see the color difference between this belt and that belt. And it's actually on both sides. Like also here, it's like very silvery. It's like this is the original color, and then here, um, yeah. Just drop the belt tension and undo the XY joint will come out. This is on 2.4. Hey there, Harlem, welcome. Um, yeah, I mean, I can remove the tension here. I can remove the tension here as well, but I'm not sure if this is enough. Like, I don't have so much tension. Like, the wiggle room here is not like a lot. Um, now let's quickly remove this. And then we are almost there. If I find my screwdriver. I think that's also what we did last time, right? In December, we also removed this top bar here. Wait, let's not lose our nuts. That would be... Because now we can simply do the following. Now the belt's completely loose. Okay. I think I need... No, not this one. I need this one. Yeah, there's another crack here, actually, I think in this part. A bit less... Oh, there's a screw missing. Is the screw missing? No. I think there's not a crack. Oh, it's not a big, like, singular crack. can see, I lost something. That's, you can see like there's like a little bit of a crack here and also down here. So it's definitely not in a good condition. This could be replaced with parts. Hi there, Quinn. Welcome. Let's see. Oh, we lost the long screw of the mini stealth burner. Where's my camera? Here. Ah. Let's see. So this side is loose. Let's do the other side. Found a post on Reddit answered by one of the Raw devs said this was normal for the bells to discount like that. Yeah, I think it's just like sounds bad, but metal shavings from the idlers, I guess. Because like they rub over the idlers like a million times. So I think it's just like normal for them to like pick up a little bit of the metal. I mean, as long as the belt is not damaged, it's also like not a big deal, I guess. Okay, so now the next question. So technically, this is out. I feel like we did it differently differently in December. Because technically, let's keep this one together. I think it's easiest to just like disassemble the stack here to get the belt out. Because the new parts actually come with their own bearings. I'm not quite sure if it's smart to like keep these, which is like no name something, or the ones from the LDO kit. Oh, we didn't have to take this apart in December, right? We only swapped the x-axis. So I don't think we took it apart at all. Nope. I lost one of the screws of the linear rails. Okay. Will be fun later to discover which screw goes where. And these screws here are a bit stuck. There we go. Okay, so now we can technically also remove this here. I don't remember. Is another screw holding this together? Oh yeah, there's one from the bottom going in here. 2 by 10. And now it falls apart. Okay, let's try to do this gently. So that's one stack. So now the question is, firstly, which one do we need here? I think this one is this one. Yeah, so it's like this. So this one goes here. So now the question is, does it fit? It just fits. which is great. And then the other question is, can we mangle the belts in there? So technically we have like a little bit of like belt to work with here. The problem is one of the belts. So this goes like, yeah, both of the belts basically need to go behind the front bearing stack. So I think the easiest is to just remove this bearing stack. Because I really don't want to remove the belt here. I mean, that's the other option, right? That we remove the belt here from the center. I think that's quite painful because we cut it flush. So I think it's easier to do the stack. Right, even smaller. This is really tiny stuff. So why does it focus on this tiny bit of printer up here? Let me quickly see how this works. So we have the short screw from the top. So I assume from the bottom there will be quite a long screw. Also short screw. Ah, interesting. Okay, so this black part basically goes through the bearing. Okay, that means if we assemble this, this goes like that. So the belt here in front goes just over this one, and this one goes in here. So I think we can just mount this together, and then we figure out the belt. We're not sure if this is the best approach. I mean, it's an approach. Uh, it's really hard to push this onto the beam here. I think now it's aligned. And yeah, one from the bottom. And we are connected. So all we need to do now is put this back. And the question is if this like being loose gives us enough wiggle room. Technically we can do this. Just need to be careful because like these two halves are separate now. So maybe we can just screw it in like this. Just from preventing the stack from falling apart. Now we have a lot of wiggle room here to reinstall this stack. Okay, I didn't fully tighten it on top yet. Let me see. Let's flip this over. I'm just careful with the tool head dangling there on the back. Okay. Let's bring this all in position. And that's number uno. Everything is back where it's supposed to be. Belt-wise. The rest is still missing. Question is, technically, like we can leave this one loose. We don't have to loosen the other one. We can work like this. So I would say this worked quite okay. So let's just repeat this one-to-one on the other side. Yep. Okay, somewhere in the printer is a screw now. Let's see if we can find that later. Yeah, I see it. It's always fun if you lose a screw in the printer. Many places for it to go. Okay, then let's do the same stack operation here. So we just take this fully apart. Trying to... Oh, that went smooth. I'll just put it on the pile of stack. No, I just found another screw. I don't know where this came from. Oh, but looking at this from the bottom, we also missed the screw here. I think we should add that. So most likely we are one screw short for the other side, so we need to quickly check. But this one is too long. There must be like a way shorter screw. I'm just using a random one, so let's know we are 2M3 by 8 short. Okay. Then we can kind of like leave that here for now. Let's do the same trick here that we removed the front one. And here it is. So we need to add this block again inside here. This side is much easier to like put on. Like the other one had like quite a lot of tension. Let's not tighten this yet because we need to adjust the width basically between the two rails. And here we now need more screws. Yeah, this is the same length as here, so I think this can go here. Also here, let's not fully tighten that, but I discovered we have a problem there. I think that was why one screw was missing. Yeah, I think we cannot put a screw here in this position here because this will potentially actually touch the rail here. I think there's no screw supposed to be here. And the other thing is, if you observe this closely here, I kind of didn't pay attention. Like you see here, the screw here is supposed to be countersunk one, but we are now using the button head screws. On top, it looks like button head is okay. Let me quickly double check. Yeah, on the top it's supposed to be button head, but here on the bottom they carved out for flat head, for like not for countersunk. So I wonder whether we should quickly replace these screws here. I mean, they hold it in place. Let's keep them. Should be fine. But then basically we don't place any here on the outside, only on the inside, because these we can later tighten, whereas these are completely inaccessible. Okay. So let's maneuver this into place. Then you are actually the bottom, so this is fine. And then we need to again add this one here. And then we are golden. So this one needs to be with the bearing on top. Not magnetic. Okay. Oh, that's like simple logical thinking. Like we could have just completely removed the belt from here. I didn't think so far. Okay, but all the belts are where they are supposed to be, minus this thing here. So this one is here on top. Let's put this one back in place roughly. Oh, we can't do that yet because that will require full tension. So let's just leave it here for now. Let's first mount the XY axis back to the linear rails. And also here, now we are kind of experiencing quick issue, like small issue, because these are not supposed to be countersunk now. But the original screws are countersunk. So if you check here, I'm trying to not move the camera too much. So here you just have like a plain hole now. So we need a button head to properly hold them in place. But I'm actually not sure if I have M2 button heads. So potentially we just don't have any choice but use the flatheads that we have. What do we have here? Oh, we have M2 by 8. That could be, let's quickly try it. That could be a good option. So it's like the M2 by 8 with a socket head. They are used for the linear rails in this machine. See if they're lengthwise okay. It might be just too long. Okay, let's see. It's a bit difficult to align this here. Yeah, no, they're definitely too long. They're too long. Like stands out like over a millimeter when it bottoms out. So yeah, I think we can only use the ones we have for now. I don't think there's anything else in here. So yeah, it's the countersunk one we have. Yeah, I think then I'll just order like a couple of like M2 by 6 button head and replace them. But for now, let's just roll with what we have. Don't need this one anymore. Okay. I'll just do 2 for now. And then let's do 2 on the other side. Yeah, it's not too bad. So basically, you can just see because like it's like we are now like screwing this like countersunk screw here. Like there's like it's not super like it stands out a bit, but still like it tensions the thing. So yeah, I think for now it's fine. Just to double check, these should be loose on one side. So yeah, and here's like very loose. So this can basically when we now screw the two like XY joints to the two sides. Also, this is not super straight, so let's just uh, fully loosen that, actually. So here we have a bit of clamping force for some reason. That's what I mentioned before. But basically, this is now not really restricting. That's weird. Like, here's really... The screws are all loose, but there's still like a lot of force on this connection here. And I fear this will be a problem when we try to rack it. Because now like the x-axis kind of has a tendency, like if I try to move this back, you see here, like this, like normally the belt tension would cause this, but now it's just like here from this connection, because like here it's quite loose, I think. This should be. Just double check, I don't have any screws tightened, no. Like I would expect to be able now to move this here, but I cannot. So I think this is a little bit crooked maybe. Okay, let's quickly remove these two screws here again and just take a look at it. Because I think we will get problems if we ignore this. Yeah, you will have wrecking. There's one belt loose and one just. Well, yeah, but like, I mean, now there's no belt tension here, right? Like they're all like super loose. So I would expect that I can like freely push this back, but you see there's like still tension on the system, but it's not tension from the belts, so it must be from the connection here. Um, let's just quickly investigate that. Yeah, see, like this. Is there anything here that should? I mean, these are all loose. Is there specific holes drilled into the slide bed extrusion here for the screws that the screws can't slide? Because I would expect that I can like slide these like in and out a little bit if the screws aren't tightened. Yeah, this doesn't fit well. Yeah, like look at this. If you look here, you see how this like goes like outward here, right? Like there's like a small gap here and then like it grows. So I would say this extrusion is too wide for this part. That's also why it's so hard to push in. I think that's the issue we're facing here. See? This is no issue. But with this one, we have, yeah, also in this direction, it's no issue. Just like if you do it like this, like it's too wide. And then basically that's what's causing this like tension in the system. Let me think. I don't think there's like it's a lot. My caliper's over there. Okay, whatever. I want to quickly measure. I think like if we have it like this, we'll have issues with wrecking. Well, on the other side, it's also like this extrusion already has pre-drilled. I don't know. How's the new place? Well, the new place is streaming ready, but yeah, still like quite chaotic. I have a couple of boxes not unpacked, and only last week I started putting up pictures, so step by step. But yeah, overall, like it's going together. Um, but yeah, according like for this issue, there's also like the this lightweight extrusion has pre-drilled holes here. So what I was expecting is that I can like slide the XY joints a little bit in and out, so I can adjust for the width of the printer, but I cannot do that with these lightweight extrusions. Um, so I'm wondering if that what I think is the issue here right now is an issue at all, or if it's just working. I mean, there's a bit of tension, which is not ideal, but I think it should be fine. I'm wondering whether we should just like, like take a file and just like remove a little bit of material here to make it a little tiny bit thinner. Then we don't have the tension on the XY joint. Also, if I move it in like here from the side, like now it's super fine. That's really like the last bit, like till here. Like here it's like okay. And it's like the last bit here, now it gets sticky. Um what shall we do here? I'm not sure. Like I fear if we now like just ignore this and continue, that it will cause issues later. Let me quickly see how this looks if I fully tighten this down. Yeah, I still see like there's a bit of like a see here? Like a gap, like uh, here, like it kind of like goes wider out. So it's definitely like forcing parts apart. And then I'm not sure if this is good because now there's like a slight angle. Like this is not like in a right angle anymore. Wash on each stack. Yeah, I thought about that too. That also would be possible, right? But it's also like the connection here. There's not a screw connection. So technically we will also need to put a washer there as well. I mean, as luck will have it, we have like a couple of washers ready from the old stacks. So let's just give that a shot. I hope that if I loosen these 3 screws, I can just lift it off in one go. I can if I remove this one. So technically we would need a washer here. Can I balance this under? Yes, there. And technically here as well. I'm not quite sure if this one is really needed. I mean, the other thing is, maybe Steve, maybe what's your opinion on that? Do we need a washer here, or can we just like loosen these 3 screws I just removed? Oh, it's the wrong. I was like, why doesn't this work? Works a lot better with the correct screwdriver. Okay, so now we have the washers in. Oh, yeah. Let's remove these screws maybe. Would make it a lot easier to remove. The washer's going to snag on the idler. I don't think so. They don't touch. I mean, this definitely solves the issue we have here. But now we have quite a huge gap here. Like, I wonder if this is not too much. Um, the washers shouldn't be interfering with the idlers. Like this one here, I was a bit concerned, but it's just inside, and here it's definitely not touching. But I wonder whether we need this washer here at all. Like maybe the 2 washers at the idlers are already sufficient. And then I'm wondering whether, like, by adding this washer, because now we kind of push the belts a little bit out of alignment. You will need 3mm washers, then 5mm slide over the shaft. Hmm. I don't like the solution. I think we're also like pushing the belts a little bit out of alignment. But I wonder what happens if we just put this here, but not fully tighten that yet. Just leave that a bit loose. Because now also like this obviously works. Yeah, it's really like this screw here. Because now you see it's like tensioned. So it's not really about these two that hold the stacks as much as this one here. Hi there, Didn't receive any YouTube notifications for the live stream and had to search for manually. Oh, that's weird. So I mean YouTube doesn't like me anymore. Um, yeah, but the other thing is like what I mentioned that like this is a little bit supposed to slide. With this, like extrusion is also definitely not the case. So I think we can just safely ignore that there's a bit of tension and just go for it. Because like there's no way we can horizontally adjust this anyway. Because the pre-drilled holes. So let's just ignore that that's a thing. And then for here, let me quickly grab like a fitting screw. It's of course the bottommost. Okay. Here we go. Let me quickly see. So we need a M3 by 8. I just grab 2 of these. And then they fit much better here. And then also with these, like it's properly like tightened here. There's no more gap. So I think using the proper screws here is already doing the trick. So let's do on the other side because here's not quite fully pushed in. Let's just quickly loosen the screws here as well. Yeah, but now you see like it can like wiggle a tiny bit, and that's what we're losing. So yeah, it might be a bit problematic if the distance between the linear rails is not perfect, and it most likely will not be. We can't really adjust that because there's like a lot of tension. Like this is like enough wiggle basically, you know, like if the distance is not perfect, that we can compensate for that. But it's as soon as I tighten these down, yeah, it's explicitly this one here. Now it's fixed. Because now I can still wiggle. Now it's fixed. Okay, let's just give it a shot. I don't think I have a good solution. I mean, the other option would be, right, it's something we can do. We can take off a little bit of material of the rail here, of the extrusion here on the bottom, for example, that we just like use a file and like remove a bit of material. When you MJN12, linear rails are not smooth, so should I disassemble them and clean with isopropyl? Yeah, you always have to do that. Yeah. So basically, when you get them, they're oiled, but it's like protective oil that they don't rust. You always have to take this off and have to put on proper grease. What I usually do, not sure if this is correct or not, is you have the screw holes here, right? So if you don't feel comfortable disassembling it, move the block over a screw hole and then use a syringe from the back to force grease through the through hole in the inside. It's a bit messy, but it definitely works. But Steve, what's your 2 cents if I use a file and like remove a bit of material from the beam? That it's not like basically having like a force here applied to it, like the clamping force. I don't think it's a big issue if there's a little bit less material here, because in the end, like you can always compensate with the bed level for it, right? Um, yeah, I think I'll go for that. I think that is a plan I like. Should be quite quick with the aluminum. And we don't have any issues. I like a work without issues. I don't think you will get much using file. They are only the adjustment from the fixed holes in the crossbeam. Yeah, well, there's a little bit of wiggle, like a millimeter on each side if I do it, right? So if it just gives me the option to properly adjust this. I think it will be relatively quick to take off a bit of material here. So I'll just go for it. I'm not sure if it's like 100% necessary, but maybe also just take some random thing under it. Don't scratch my other pretty extrusion. Yeah, since it's already more than enough. So if you look from it now from the side, you can see it's like a tiny bit less here. Yeah, perfect. See now? Oh, wait, I first have to tighten this before I say anything. No, not enough. Okay, let's do a bit more. If I ever learn that the yellow one goes for these tiny screws here. Are you using your printers like Highwind THK? Some printers have LDO rails and some Highwind and some have cheaper rails from Amazon. This one is a Highwind rail. The others are LDO rails. But I wouldn't bother too much. What you can do is like for the switchwire, for example, I went with the ones from the sourcing guide of the switchwire, and they're also like great, and they were definitely not expensive. They're from AliExpress. Um, so just go with like the maybe the just pick like a random boron and go to the official bill of materials, and they have specific links in there. So just check which specific linear rail they recommend, and then just get this one because they also update it regularly. Well, I'll need to get something to clean in a second. It's a bit of a mess, especially like down here. Okay. Just need to pay attention that I don't twist the belts in a way. I can't undo later. Okay. Let's see if I can. Oop. Let's get this one out of here. And just be really careful. I think it's really just mostly about the tippiest tip of this extrusion. So if I now put it in, that's still quite. Didn't expect it would be. This much material. That's like the problem here. Okay, now I really need to pay attention with how I rotate this here. This okay, and here's like one twist. Here we go. And this side, it's like this. And it's still like there's like it's really like you can see there's like a gap now on the. Not sure if you can see that. Hmm. Because you really see like there's a lot of material now missing, right? Like you see the edge here, and the edge kind of disappears. So I really took off like quite a bit of material here. But yeah, like not quite here on the end. There's still like it goes up again. So I think I have to remove this back corner here a bit more. Okay, let's give this like another 2 minutes, and if it's not fitting well, then I would also consider just swapping in the other extrusion. Yeah, here we go. Here we go. Still not perfect, but it's like, you know, now it's like serviceable. Um, it's still like connecting here on the end, and I see that like it's going up a tiny bit there. Let me like do like tiny bit more here, but then I think this is okay. Yeah, see, not now it fits. Perfect. Nice. So we have to do the same thing on the other side, I guess. Um, but before I do that, I quickly want to measure. Let's see what we did here. So, just here on the tip, we are now 14.87. So just a hair under 15. 14.65. Yeah, that's what I mentioned. Like the rear corner is still like a bit higher than the front. I think because I file from this side, I put more pressure on this side a bit. But yeah, so this like 14.7-ish and 14.84. So now the question, like I quickly want to measure on the other side. Like where do we come from? Um, if you put long bowl through the X-beam and then squash them a little flatter where the bracket fits. Yeah, like I kind of really just want it to like fit without like a lot of force applied when I install it now. What happened to your custom Core X-Y3 printer you were building? Well, nothing happened to it. It's just like didn't build on it. It's under the table, still in a box actually. I didn't unpack it yet. Um, I'm still like super busy with like a lot of like small stuff around the house. At the moment, I'm also doing like smart home stuff. I have to rebuild. Still installing some lights. Yeah, picture frames for this weekend. I do. There's like I built a small cabinet for the hallway that needs a door. I still have to hang the curtains. Oh, actually, like I get roller blinds here. I can install them on the weekend. I'm still waiting for curtains in the bedroom. So yeah, like it's still. Ooh. Wait, now I fucked up. That was lucky. Let me try to maneuver this without losing balls. Success. Okay, let's be gentle. Um, curtains. Curtains in the other room are still missing. So yeah, still a lot of stuff to do. So I wasn't really I don't really have time to work on that other machine at the moment because like if I do streams with the VZ or something, you know, like I just sit here, I just turn on the camera basically, and I just do something. But with the other machine, I need to like prepare a lot more and need to prototype and work on it like during the week, and I don't really have the time. Yeah, so this one is like this is just 15. Let's put it here so that we don't lose our linear rail again. But then the question is like this one here. Yeah, I see this one is like 14.7, 14.8. And this one is also 14.8 and 14.7. So it's just like this one is like, it's perfect 15 millimeters, but it doesn't fit. Okay, let's add this side here that we don't lose the block. I'm now a little bit wary of that. Sure. I mean, you can also use zip ties or something to hold it, but we got so far without. So I'm leaving this a little bit loose on purpose. And on the bottom, we have this one. Also here, leaving this loose. Let me just double check that I properly tighten these. What happened? What's the largest possible print I achieved with 5mm rails? Well, it depends, like a bit less. I mean, it really depends a bit on the design. I guess something like 480 or something, if you're really good. I mean, you basically have to at least subtract the block width. Half the block width you have to subtract at least, right? Because if the nozzle is centered to the block and you move the block to the outermost edge, then the nozzle is half a block within. So technically with 500 you can achieve 500 millimeters minus whatever the block width is, because you lose half on each side. But then you need to be really good with your design. Okay, let's see. I'll just do the exact same thing. So I use this like cable tie here quickly to protect extrusion. To about 450. I think 450 is realistic. Then you have like 2.5 centimeters on each side. And we know now where we aim, what we aim for. It's 14.9, 14.78. So the front part is already good. So we need to 14.9, 14.9. Let's see. Yeah, in the front we're now at 14.8, 14.9 on the back, so it's yeah, definitely took like a lot more off on front. So it's, yeah, that's already might have taken off. Oh wait, the screw isn't fully tightened here. You know that makes it a lot tighter. Yeah, perfect. Yeah, it's good. Perfect. Problem solved. Okay. I think that was all we need to do. It's interesting, like this CNC machined extrusion is just like, like tiny bit bigger and like it doesn't fit. But I know like these like XY joints here, like you can also buy them with like a CNC lightweight extrusion already included. What was the other set? And oh here. I wonder if then theirs is like a little bit like thinner. Okay, here we go. And now like we can, like this is all a little bit loose now here. So if we now tighten that to left and right to the rails, um, this little wiggle room basically allows us to adjust for the exact distance between the two rails. And before that was not possible. Okay, I wonder why this one here is now quite tight. I mean, this is, the bottom one is super loose, obviously, because the front either is missing. Okay, that looks good. Let's give it a shot. We still have to use the wrong screws here. But that should not matter too much. Oh, and I also ordered this XY carriage here, CNC. So we can also swap this one out. But it didn't arrive yet, so it's a future project. And there I'm a little bit concerned regarding like what I mentioned here, because like the belts are like flush here. So I'm a bit concerned how to get this back in line if we remove the belts. So that will be quite fun experience. Got it. This one is not really screwed in. No, it's not at all. Yeah, no. I hit the hole. Did I? Think I did, but it doesn't tighten. Yellow is for these. For these on the side here. If I use the right sized driver, it works brilliantly. Uh, Fun times. The screws are so small I actually didn't see that they're not spinning. um, I got fingerprints on it, Cam? You mean on this one? There's a bit of dust. Now better? It's this one is just my phone, so it's very likely that there are fingerprints everywhere. So okay, these are all the screws. Yeah, I think there was like a little bit of like dust in front of the lens. I think that was the issue. So yeah, now there's tension here from this belt. Which is fine. Just good checking all the belt paths, and now we can add this one here back without dropping any stacks, of course. So let's first secure it. And that should be our motion system back in order. I mean, there's like stuff here hanging on the belts. I think this looks good. Like all the belts are in the proper path. I don't think there's anything that is out of order. So let's now tighten these two left and right because I didn't fully tighten them yet. So let's just do that first. And then let's just move this back. Yeah, but now basically what, Steve, I think now it comes in what you said before, because now I have belt tension, and I can't really. The question is if I need to like fully erect this now, because here you can see now that there's a little bit of a gap, and here's not. So this can be now due to the, it is due to the belt tension for sure. But I wonder whether I can just tighten these now and then let's drop the belt tension. Then let's just do it, step by step properly. Yeah. So now basically, because I want to have the mechanical alignment basically, because we can still like wiggle this left to right, because it's like not fully, like it's not tight at all here. So let's just push these back. And now we can do this. And now we should not have any issues when moving back and forward. Like there should be not any, there shouldn't be any binding, which there is not, which is great. Then there's the last screw here on the bottom left and right. Perfect. Let's just add a random tiny amount of tension on the system, just that we can check that we can move everything. And it feels good, like you don't have any binding, resistance, rubbing, nothing. So this looks pretty good. And I think this is a successful swap of these XY joints. Bit harder than I expected. But after fighting a bit with the extrusion, I think this is like good. I'm very happy that we took the time to file off the extrusion to make sure everything fits perfectly. Okay, let's put it back together. Oh, I lost the nut. The no drop, no nut drop mod, no drop nut mod did not do what it's supposed to do. It's a good reminder to put these nuts on the outside. You need to be a bit careful with this. Like once before, I broke off the top part here of this part while forcing in this extrusion, so I'm always like very gentle, tapping it into place. Then I think we have the long screw here from the back. Here we go. Well, 610 by 610 framework. I only bought a 510 GT2 tiny belt. Might be a bit short. You might need a second one. Because you need, for one belt run, you need one. So this belt needs twice this distance, once this distance, and then like a tiny bit. So you need 600, 600, 600, 600, say 300. Oh, and you need one more 600. So you need 4 times 600. So 2.5, and then like a bit. So it might be tight, I would say. You might want to get a second belt. I would get a second 500 to be honest. Because like if you get, I mean, you need at least 3 meter for the belt just to be sure that like it's long enough. Well, you can recalculate, right? Like you need one distance, two distance, three distance, tiny bit, and then four distance basically, because you need half on each side. So it's four distance plus a bit. So it's, yeah, 2.8 meter for one. So one is definitely not long enough. Well, what do we do next? How about before I put all the panels on and stuff like that, how about we just, oh, the long screw was from here, I think. Yeah, so before we put everything together, what I wanted to say is like, let's just give it a shot. This is where the long screw came from. No, it's even this is too short. Ah, there's a long screw. This one fits. Okay, so the long screw was fine for here, I think. I remember correctly that the long screw came out of here. So let's just, it's much easier to do this now than later. So I'm fairly certain we don't need the white one anymore. We don't need the yellow one anymore. We do need the green one for this. But guys and girls who are watching, like, so today I basically show everything from top. Like, is this something you like from perspective, or because I from here I struggle a bit with like showing it from more like an angle in a certain sense. Like this does not. I mean, technically, oh, this would also work. Technically, this would also work. What do you prefer? You can do it like this. Let me know what you prefer. But here I need to put it a tiny bit higher. Otherwise, you see constantly my glasses here in the bottom frame. Well, I take that over as a compliment. But Steve, do you prefer like this angle more or like really the top down? Because yeah, also here you see like now my head is a bit in frame and I can't push it further this direction. Yeah, I still need to figure this out here a bit. And I think this one is a bit nicer because you see more like from my perspective what I'm doing. So if I do a screw here, you don't see like the 2D top view, but like a bit more. Just let me know what you prefer. Um, but also here I can push it like another 5 centimeter this direction. Maybe that already helps. Not gonna do it now because it will be disaster. Let me actually try it again. Um, better ask her. Yeah. Well, I will. Maybe somebody else has an opinion, but yeah, I think this is actually also like quite a good perspective. Let's see how this works for now. I think also like go a little bit further this direction. Okay, cool. Then technically we could just see if it can print. Might be maybe good because we can still access like a lot of things. And before I now put everything back together and we like notice, for example, that this dead spot on the bed is still a thing. I rather figure it out now than after everything is back in place. Belt tension we also need to do. That is true. Let me actually get my trusty belt tension meter. This is so nice compared to my old setup. Everything is kind of like in reach when I need something. I think it's around 2 for the V0. Let's just aim for like this bell's on 2.1. I think that should be quite good. Just double check. This is this one. Let's see if I can maybe get this from the other side. That's pretty much spot on, 2.1. Was pretty well tensioned actually. See, a very good like feel for that. Just make sure that this is, yeah, it's also wrecked. So I think the tension is pretty spot on. Like I don't know how I did that, but um, let's. Why is this? Oops. We want a 0.2. Oh, come on. Okay, 0.2. We didn't unplug anything or something, so let's just quickly do a home. That went well. As last time, I don't have paper. Let me see. Where do I have? Oh, I do have paper. Let's give this a shot. Bonus points for whoever remembers the correct command. Bed screws just. Well, this is definitely. Or do we want to do bed screws adjust? Let's quickly not do that because I think the bed is somewhat level. So let me do the following. I move the printhead up. Oh, wait. Let me do it in Chrome. Then you see what I'm doing. I also should heat the nozzle and bed. You are correct, Steve. Let's do that actually. But I quickly wanted to check if it's level. I think I don't need to necessarily heat the stuff for that. So I'll just like adjust the Z offset for this to be somewhat like a bit of resistance. Then I just say, for this one, accept. I just want to see if it's even, because then we know the bed is level. Yeah, it's also accept. It's not 100%, so we definitely need to level the bed. On this corner here, it's a bit tighter. Yeah, because here we can barely just push back and forth with the paper. And here we can't really push. So here it's a little bit tighter. Let's quickly wait for it to be heated up and then just adjust the screws. Then we can also do like, we should have done like before and after with the shaper calibration. Because it would be interesting to know if, if the shaper changed from the printed to the new parts, but then also like from the broken printed parts. We also have 2 screws left, but I think we took a couple of from the tray from the clips. And you need more room when cold we got closer to the heat bed. That is also true. Let me move that a bit home up. We can put the cam locks back in. Let's see. The bed is at 55 degrees. Let's also use the bed I'm usually using. We also it's got a bit of stuff here. And I think it's all like pressed into basically the magnetic pad. Let's see, we are 70, almost there. But yeah, so basically for the next project, we still need to do the CAN bus conversion on this one. And I was kind of thinking how to do that, to be honest. Because from the electronics, yeah, we didn't take off the back panel now, of course, but not sure, I can't really see anything here. I could technically quickly take this off. Then we can discuss that. Well, stuff is heating up. So we have the pipe, of course. We have the SKR Mini, SKR Pico, Pico. And we have this board on top here, basically. So, and this board here, I don't think we actually need, because most of what this is doing is like the cable connection to a tool head. And we don't have this tool head board anymore. So I think we can remove this board here. The only thing we then have to consider when this board is gone. Let me know quickly. Switch. So the only thing that we need to consider, if we remove this board, at the moment it does like three things. It does the tool head connection here, which we no longer need. It does supply power to the Pi. Basically, it gets the 24 volt in here, and then you see here the 5 volt comes out for the Pi. It goes here to this connector. So we need to have different power source for the Pi. And lastly, it also drives the LEDs left and right of the bat. This takes up quite a bit of space up here, and I think I want to use this space for the CAN bus convert, like the CAN bus adapter. So I would take this port out, and then the SKR Pico has this port here, which is a laser port. But actually, when you get SKR Pico, they give you this cable. And what this is supposed to do is, it actually is supposed to connect to the Pi directly. And basically it has the two red ones here, which is 5 volt, and the black one ground. So what I would do is I would like create a custom cable to power the Pi from this port here on the SKR Pico. So that's how it's supposed to, like, what it's intended for. Actually, the mounting pattern of the Pi matches exactly the one of the Pico. And all the connectors, basically, except for this one, they are all facing out. And the reason is that Pico is designed to have a Pi basically on top of it. So power for the Pi, no problem. Toolhead, completely different solution. And then what Steve, what you just mentioned, the LEDs. That's a bit of a problem still. We need to see how we do that. We don't need power for the LEDs, right? Because the strips we installed last time are 24 volt. So we can use technically any GPIO port. But looking at it, we are pretty much sold out of ports. We need to like do some in-depth checking of the connectors here. I do see there's one free one here. The X and Y end stops, like these, are burned because they are like used for the sensorless homing. So you see basically here we have the jumpers. So these two cannot be used. There is the thermistor port here for the hot end. Technically, we could use this one. The fans are all used. Technically, what we could do, this fan port, we only use the positive 24 volt terminal here, right? Like both of these cables are on the right terminal. There's a spare on the Pico. I don't think there's a spare on the Pico. I think what I would do actually is I would like convert this fan header in a LED header, so that the LEDs get 24 volts from there, and the ground connecting here on the fan can be used as input pin. So I'm pretty sure we can drive the LEDs from this connector here. Um, all we need to do then is basically take the yellow cable here and the yellow cable here and put them both on this pin. Then basically like we just drive them in parallel. So you cannot like have like only left side and only right side. So they're in parallel, but it doesn't really matter. I think then we are kind of good, right? Then we have power, we have tool head, and we have LEDs. Hmm. Yeah. So but I think Steve, I think you agree like this would be a good solution, right? To use this fan port just as a LD port. Pretty sure this works. I wouldn't know why it wouldn't work. And then also this like annoying cable is finally gone. We will need it in a second, so I'll leave it for now, but okay, we are fully heated. So let's do some fun with the bat. Bat screw adjust. This is good. It's also good, I think. Should also be good. Can I place the side pulleys closer to the linear rails and use 5 meters of belt? I don't think that will be enough. Let's just accept this one for now. Yeah, this is definitely like we are almost there, step by step. And also like this is like really in the corner, so I'm not quite sure if this is like really the best. Yep, I think we got it. Yep, I think this is good. Let's just try to print like the most simple square. So let's just add, oops, prepare, add primitive, add cube. And let's just scale that to 100, 100, and 0.2. Maybe let's do 90. Slice, print, upload and print. And rumor has it, now we need filament. Uh, 8 times 550. Oh, I need to tighten the, the spool holder. Oh, oh, I'm not ready. I'm not ready. Let's try again. Um, 8 times 550. That's definitely too high. I can already tell that. Ha! It's the same. It's the same. Okay. We can already stop. Like, it's exactly the same we had last time. And yes, it's still quite high. Let's give it one more shot. 8 times 550. Yeah, we said 1, 2, 3, 4. Yeah, okay. Then you might be correct. Like 5 meters might just be enough because 600 extra you will need here and there, right? The opening trying to correspond of the problem you will come across going over 300 will take you much time to sort. Well, the thing is, the bigger you build it, like small mistakes, like in accuracy, basically, they add up over distance. So, for example, if like you are 1 degree off on the axis for a short machine, like it barely makes a difference over the 120 centimeters. Ah, see here? Like now it's a bit better. But it's still like you see like it's not properly sticking in this corner. There's also gunk on the nozzle, which is not really helping. We're also still relatively high. Let me quickly clean the nozzle off and go like maybe another 15 lower. Let's just continue this one. Oh, there was a distinct lack of filament here. It's still like it's like squishing down here. It's squishing down here, but in this corner it does not. And never mind the complete lack of filament in this corner. Uh, the good ABS screws. I'm already getting dizzy from just like half a second of printing. And this looks really good. This is like perfectly even. Now we're getting in the danger zone, so I'm curious what happens. Yeah, we also like here we're a tiny bit too low now. Like you can see, there's a bit of a bubble here. A bit hard to see right now because everything is above it. But this looks quite good. Like the parameters are not really like set down. Let's wait until it's over the corner, and then if it looks okay, I will just restart and see if we can get this better. Yeah, it's borderline too low. Like there's like here's a bit of like where it like lifted off, and here as well. But it kind of sticks here in the corner, so okay. Let's just restart it and see if we get it better from the start this time. I mean, it looks really good from. Oh yeah, but you see already here, like you see, you can it shines like there's gaps here, just here at the end, like you see, like there's a bit of gap, and it's nowhere else. It's just here in the corner. Okay, let's still try it again, but I think it's still like this corner is still not good. Mm, take a look at the printed washer fix for the K1 Max to level the bed and also see if it will work on the V1. Well, the easiest, if this is a continue, like I just want to understand where this issue is coming from, to be honest, because like this means something is wrong. um, and I'm pretty sure I can like fix this. I mean, one option is like we can fix it via software, so we can make a manual mesh and just lower that corner, like adjust the mesh in that corner. Yeah, it's already like it didn't stuck in the corner here already, so kind of already giving the game away. Let's see. I mean, so far it was sticking it for the. Yeah, but see, here you can't do this on this side. So well, the other option. By the way, this is a perfect example, right? For the K1, like this would be like quite a big problem because it's like a much bigger printer. For the V0, my high-tech solution is this. And I think this paper will already solve the issue. Which doesn't mean this is a good solution, but I'm fairly certain that this was just this all that it needs. Three-angle washers that should lift that side of the bed. Where would I put the washer? I mean, I can quickly check that in a second. Let me just quickly see if my paper fits already. Well, I would say I fixed it. Not perfect, but it worked. But this corner also looks a tiny bit funny. And it is not perfect, but it kind of works. So yeah, it doesn't need a lot. What's the largest printer you have? VisiBot 330. And I think for 330, like it's already quite a huge machine. It's still on my to-do list for this year to have a big printer. I just need to sort out a bit of like space issues and stuff like that. But overall, it's like very nice first layer. And really, if this border wouldn't be like such a problem. But it's also like on this side, like this also looks not ideal. Like it's not that it's not sticking here, it's like barely sticking. I think if I would do that on the rear, it's just a bit, yeah, the rear sticks better. So maybe at the moment the problem is also a bit that the entire front is a bit too low. Let's try to lift the front of the bed completely up a bit. Let's quickly wait until it's over the corner. Yeah, but like the paper fix definitely the trick because I think here we are not having any gaps. It's still like not super good here, but it's kind of serviceable. Okay, and besides this, it looks really good. But this is the front one here. Like you also see here are gaps. But there's definitely also here gaps in the corner. Um, right, let me see. Yeah, this is the rear corner. This is the rear corner. And you can definitely see that on the rear side here, there's definitely more squish than here on the front. Like the lines are a lot thinner here than here. So I think the entire front is just like not good. So I think we can fix that. Let me think. Which direction do I have to turn? Turning this way. Turning this way will lower. It's upside down. I had this. So tighten it out to this. Yeah, so I have to turn a little bit this way. Let's see if this made a difference. Yeah, that will lift the bed. I think I did it the right way. Yeah, I think it looks better. I mean, the nice thing about the V0, you do this once, and like if you don't touch it, it will never have to be done again. Yeah, it's not good. Let's think then. Yeah, still not good. Ah, looks better. But now it's definitely too close to the bed. So now we overshot a bit. um, but at least the corners are sticking, so it's definitely like just a level issue. It's just like me being unable to level a bed. I constantly have to think, like, if I do this, yeah. So now it's a tiny bit lower. I don't have the paper anymore. The paper is here. So I removed this. Yeah. I mean, now it's kind of okay. We're just like tiny bit close still, I think. I feel like there's a screw is not fully tightened somewhere. Like I hear like a very high pitch vibration. Yeah, but now it's like a lot better. Like I don't see the. It's still a tiny bit low. Like you see, there's like on the edges, like it's a little bit like curly. So I do one more twist in this direction, and then I think we're good. But like this screw noise is a bit irritating to me. I hope, because that would be a real bummer. There's a quite fair amount of screws we cannot access anymore. Oh, why no extrusion? Yeah, I think now it's pretty good. We are a tad bit low. So let's just add tiny bit Z offset, and I think then we're golden. Then I think the next thing we should do is we should run the input shaper. See if we get bad results. I hope that we are not getting bad results, because that would be a shame. Yes, like in this corner. Yeah, it's very reproducible when it moves in this area in the back here. Like if it's here in this area in the back. Yeah, I think if we have to take it off again, like it's not the most horrible thing in the world because the bed is level. Um, yeah, it's still not perfect. But I think we are now in a serviceable area, or like in a serviceable state. Like here on this corner, like it's not the corner is not like really perfect. You have to wait until the printhead is there. But now it sticks. It's still a tad low. Yeah, with the diagonal moves, I don't hear anything screw vibration. Let's see. Let's just run the input shaper. And yeah, see what that shows us. Yeah, so like if it's in the back area, like I hear something. Not a huge fan of that. But I'm a huge fan of this like very even first layer. Yeah, that's good. It's my good tad faster. Yeah, now also the sound is gone. So there's some resonance frequency at the slow movement. Now it's completely gone. Cool. I guess the next step is just we put all the panels back. I'm quite confident that everything will be fine. So we put the panels back, and then I would run the input shaper, but I would like put the printer on the floor to do so. I never run the input shaper on tables because like you always add the resonance of the table to the shaper results. Looks pretty good. And it's not perfect, but it's actually quite good. Oh, that was a fan. So if we just look at this, like it's very even. Like I don't see any spots, the lines. It's still like not I peeled it off in this corner. So this corner is the one we had problems with. And I still would say it's a tad lower there. Or too high there. So you see here, like the lines are quite thin. Whereas in the opposite corner, they're quite thick. So, I mean, this is now like a bit more troubleshooting. I think this one needs to go down a bit. Which I now did. So maybe that solves it. But that's something I'll then figure out like in detail later. Let's just enclose it. Because I'm also pretty much done with like smelling ABS. That is not the nicest thing. Like I really like feel a bit dizzy from like just sitting here. Okay, so this one, also interesting, like here in the backmost position, the bone tube touches the belts a bit here. I'm not super happy about that. Okay, but let's just put this to the front here that we don't forget about that. And let's just start with adding the hat back. And then we have like nut here that wants to slide around. Let's make sure that we have this. Nope. That did not work. Trying to maneuver this in here. Yeah, for some reason, like if I... Oh, I expected this to go to the extrusion, but there will be later like the panel in between. That's why it doesn't work. This one is still in place. This one we can loosen. Let's add the small panel first. I think we need a tiny bit of a gap here. Trying to make it even. Okay, that's step one. Then the second panel. Let's see if we can. Let me flip it, but I think we have to turn it off or remove the either panel clips here. Yeah, let's remove quickly the panel clips. Okay. That's also back in. And let's work our way around. Oh, let me put this back up. Let's quickly remove the filament. I don't think we need that again. Um, so then, yeah, let's actually do them all while it's on the side. I think that's a lot easier. I just lost the cam lock. Okay, so this one goes here. Then we need two. Then we need one in the center and one for the corner piece. Let's start with the corner piece. Then we need one in the center, one in the center, and then like for the corner piece. And here we need this one, of course, where we can put the door in. And here we need the one for the other door. Opposite end of the door. Not type this yet because it's not quite in place. And I think one of the next upgrades will be the panel clips without screws. I am getting a bit annoyed by that. Okay, that's panel one. Let's flip it over. Oh no, another one of the no drop nut mods just broke. It's here. Sure to grab the nut. Oh, I think these are the wrong screws. I accidentally take the wrong screws. Feels like they're too long. Yeah. This one is better. Then we need one centerpiece here. And one centerpiece here. And last centerpiece here. And then we need one handle. I think the handles are one of my favorite mods. Just like it makes it so much easier to pick the printer up. That's where the long screw came from. And then we somewhere it says acrylic or glass. Acrylic, of course. I don't think anyone would use real glass on a printer. And that was the last. So I'm still wondering. I mean, I know where the M. So basically, we have a couple of screws left. I definitely know where the M2 by 10 came from, but I have no clue where these two came from. So somewhere we forgot something, but I assume it's not essential screws. Come on. Here we go. Here the cam lock is still closed. We need to flip that into the open position. I don't have anything better to do it. They were on the bottom of the XY joint. Oh, of course, yeah, true. Yeah, Steve, 100%. Yeah, this works. We replaced them with the other ones. Yeah, check. That means we did not forget any screws. That's good. Okay, let's connect the accelerometer. Just kind of like this in here. And I think it's complete. Like we put it back together. Let's quickly do the following. Shaper calibrate, and I'll put this on the floor. So that we don't get any weirdness from the table. And it tells me I have to home first. Well, that makes sense. Let's home. While it's homing, I will put a couple of things back where they belong. And now I can shaper calibrate. I guess here you have the best view of the printer. Let's see how it goes. Carefully optimistic that everything will be fine. Yeah, for this machine, I keep all the screws and parts still together, so in case I want to modify something, I have the exact fitting screws. No way! Ah! There's a pack of M2x6. Exactly what we need for the part on side. I didn't see that. 8. Oh, even better M2. Okay, well. Here we go. Well, then let's quickly replace these. Should have looked more carefully. Hmm. Here. Oh, it's done. So basically, um, these we used, and that's of course the wrong screw, but then like, we also have button head. Old clipper that don't move X and Y when it calibrates. What did I miss here? Is there like essential clipper updates I didn't do? I mean, I didn't do a lot of updates here. I'm not gonna lie. But it's not a big jump. Like it's 12037 and the new one is 410. So Steve, you're telling me we need to update Clipper now? Oh, there's a Crow's Nest update. Interesting. Oh, but nothing changed in Crow's Nest. I wouldn't touch it and you don't have to flash board. Yeah, it's the thing, like you don't always have to flash the boards when you update the Clipper version. Um, but you never know when you have to. Because you see here, my Clipper boards, they're all on 11, 0.11. They're all on 0.11, so I'm already like a major version behind. That's actually something I should also do at some point. Okay, I think it's done. Let's see what we got. Uh-oh. X is fine, but Y 3 hump EI is not good. Then something is not okay. That is not good. So maybe the vibration sound I heard was actually something. Let me quickly see. Let me quickly create a graph. Let me quickly create a graph. 1 second. I have to graph. And technically we only need the bad one for Y, right? Let me just quickly create both. Wow, that is some bad stuff. So this is X. X is quite fine, so we have like a quite big peak. There's this weirdness here, which is, I guess it's fine. But that is something else. And we do have the spike here, but then, oh god, what is happening here? So that's definitely no bueno. That is 100% not good. The problem is that for Y, we are unable to access most of the screws now, I think. It's not like it feels loose or anything, but something is not good, obviously. So let's first swap out these screws. We can do them just one by one, and then that should be fine. Um, so I'll just, oh wait, you don't see anything what I'm doing. I'll just take them one by one. Where did I now put them? Here. And I just put one out, put one in. And in a second, we have the proper screws here. Maybe this is the issue already. I would prefer to first try if this helps before we do anything else, because for any other thing, we most likely have to remove the x-axis, which would then mean most likely we have to re-level the bed. Yeah. And I'm also not quite sure if we can, I don't think we can remove it without changing or like removing the tension. So it would be a whole process then. Yeah. Quickly use the Allen key for this one. Let's do this here. Same way. Yeah, this front one here like doesn't really work with my driver. I need to do it with the Allen key. Okay, so that's all the screws swapped for the proper ones. But I'm fairly certain that something else is off here. Um, yeah, but I don't think we can access anything of importance. We can check the screw down here, but I think we already did before. We can do these. They're all fine. So if there's a loose screw here, it must be one of the super small ones. And because it must be either the ones left and right here, or one of the three from the bottom. That is the only option. So let's just give this another shot. And see what happens. I'll just do it here on the table. Like, we will see if it's better or not. Only gonna do Y. Hmm. I don't hear any rattling or something. At which point did we have the issues? Yeah, it's over 100. So kind of in the range we are now. Now I hear something. It's definitely on this side. Definitely here on this XY joint on the right side. Let's see if this helped. If not, I fear we need to take apart a couple of things. Yeah, it's still 3 hump EI. So I can regenerate the graph, but I can tell you it will look equally horrible. Oh, it didn't regenerate it? Still the old one. I'm not sure why I didn't quickly delete the file just to make sure. Yeah, now it's different. But it got, if anything, got worse. So, yeah, shit. Mm. So from the sound I hear, it's definitely on the right side. The question is if there's a way to easily access that, and I think the answer is no, because the screws are on the bottom here, right? The ones that we can't reach. So if I want to access them, oh, it doesn't help, right? That's not fun. Let's see if we can get like away with like doing some hacky stuff. So I think what we can try is if we only remove the top beam here and we loosen the left and right XY joint from the linear rail, then I think we can tilt it up and access the screws from below. That worked. We lost all the nuts though in that extrusion, so let's not forget to add them back. So I'll just reattach this here already. Yay. So that worked. This panel definitely has to go. Yeah. Here we go. Okay. We disengage the motors. Actually, let's move this all the way to the front. Um, let's quickly check. I mean, now we already have access to one more screw. And this is like, it's not loose, but it was like super tight. So if we now loosen these screws here, we should be able to tilt it up. And then I would suggest we just run the input shaper. We tighten the screws, we run the input shaper and see if that makes any difference before we put anything back together, of course. Maybe it's a learning, like, maybe it's worthwhile if we would have run the input shaper all the way in the beginning. Not the beginning, but like in the, when we did the homing test before we put on the panels. Because then, yes, the input shaper is not like representative of the end result, but it definitely will tell you if something is wrong. Last one. Let's see if my plan works. Let's give this the most amount of belt here possible. And I think we can kind of get there. Let's see. So, can we though? Yeah, if we give this. Oh, this one is even smaller. Okay, let's see. We need the yellow one. And this wasn't loose, but like not. It's not like they're. It's not like they're loose. These are all fine. Also, just for good measure, check that all the linear rail. We now like also destroyed the belt path here a bit. Let's see. Now it's all tight. So I'm sure because like these were like a tiny, teeny weeny bit, like not 1000% tight. I'm not sure if this was already the case, the issue, but ah, shit. Now there's like one belt here that's jumped out of the pulley. And that's of course really hard to access. And let's give this another 30 seconds and then I remove the the panel. Yeah, I think I have it almost. Yeah, I have it. Okay, cool. Perfect. So let's see if this operation did anything good. Which sensor are you using for input shaping? The came with the LDO kit. It's basically just part of this toolhead board here. It's the white cable. I think it's yeah, just the ADXL sensor, like standard. Okay, that's one side. Okay, that's back together. Let's give this another shot. I'm deleting the graph already. And we don't have any issues. And off we go. So technically, like from the graph, like we should see issues from, or hear issues from 70 hertz onwards, basically. There's like some stuff like rattling over there. Oh, I also just realized we didn't put the extrusion back here. Let's see what it does. Now it's 75 and something very loud is happening, but everywhere. I really hope it's better now. Let's see. Hey, we got one hump less. Now it's two hump EI. Let me quickly generate the graph. Let's keep the original one as reference. If that is better, I'm not sure. But yeah, let's quickly put the extrusion back. This might help a lot. And then let's run this one last time. Oh, there's the screw still in here. Okay. Amazing. Well, to be fair, what I didn't realize just now, like we have all these like loose clips here now, of course. It's not very helpful for the shaper. Let's do the following. Let's put the side panel back and run it one more time. And then I would say if we are not getting a satisfactory result, this is then for next time, unfortunately. Let's put this all back. Okay. Nope. Yeah, why does this not want to align? Like this, and here we go. Mm. Okay. And the last screw, and then we are. Okay. Oh, hi there, Ballistic Tech. Welcome to the disaster of swapping the XY joints. Well, not disaster, but for some reason we get bad input shaper. I'm not quite sure why. Something is not where it's supposed to be, I guess. Let's see. But yeah, it's the last attempt, and then I would just call it a day and then just take care of it next time. Let me also already remove graph and data file, and off we go. Uh, I have the sheet I have set quite some time. Like it's the OSEC safety sheet. But it's the first version. They now have like a generation 2, which is too expensive. And when they launched the second generation, I got two sheets for my Ender and for the V0. Um, like basically from the um, overstock they had from the old sheets. They're really cool. Like it's like a semi texture cheat basically. They're really nice. Let's see. I think it sounds a bit better than before. I mean, definitely like it helps to not have all the panel clips loose. And let's see at 75 if we hear like something weird again. Yeah, it's still there. Yeah, now it's really loud. I don't know what it is. Now it's more on this side. We're almost there. 26, 27. The safety just has the addition of the color changing strip. Yeah, exactly. It's they also have the non-safe sheet. I don't know how they call it. It's the same. Like you don't really need this like strip. I don't know. Mine is actually broken. They are like if they are in the sun for too long, like they don't work anymore. Um, yeah, it's not like it's like important feature. Oh wow, we have Shaper type EI, which is not great, but it's not horrible. Let me quickly generate the graph. Well, it's something. It definitely is better than what we had before. So now we just have this like weird stuff in the lower frequencies. But then yeah, at 75, that's what I said like there's like this massive like resonance spike. But this should not be here like at all. Like this should not be here. There should be like this first spike here most likely, but not whatever this is. The interesting part is like it's in X, Y, and Z in all three. But Clipper says it's compensatable with EI at quite an okay acceleration. So I would just call it a day for now, and just accept that. We will work on this machine again next week. I think we have at least 2 weeks worth of work still left. So firstly, I wanted to replace the printed X carriage with a aluminium CNC X carriage. So we have the aluminium XY joints left and right, and I wanted to have the X carriage also in aluminium. Didn't arrive for today, so we couldn't do it. But yeah, I think it's relatively minor. But then the question is, what we do with that shaper. Like X is quite good. I'm just, yeah, something is loose, but by God, don't ask me what. Because everything we touched, I think we revisited now. Like we took it apart again, we checked all the screws and more, and they should be all okay. I'm really not sure what it is. Like, it's not like anything feels loose. But yeah, EI is officially acceptable according to the Voron team. So MZV on EI, MZV and EI are top. Like if that's your recommendation, then you're okay. So I would accept that, and then next week we do the X carriage. Most likely a bit more. Let's see. Maybe we can work on this shaper situation here a bit more. And then the last step is basically to replace the toolhead board with the canvas variant. So I no longer want to have this LDO toolhead board. I'm a bit annoyed, especially by this white cable here, which now managed to squeeze itself behind the belts here, which is great. So that needs to go, and then I am very happy with this machine. So then I can start tuning it again. Because I really feel like the mods we now did, it's like it did not really help the reliability of this machine. Let's put it like this. Okay, well, it will print, so I can use it now. I have a couple of like things I want to print with this machine. We have a very acceptable first layer now, so this looks pretty darn even. I'll optimize it a tiny bit again or a tiny bit more, but yeah, overall like looks pretty good. Yeah, thank you everyone for tuning in. I'll be changing my Formula Zero toolhead to Dragon Burner with Poly Lancer. Oh, that's like also a really cool setup then. I kind of like the vanilla mini stealth burner setup. I kind of like the look. So I think I'll stick with that for now. Like I don't really see a reason to change that. But yeah, now with the new LEDs and everything fixed up, I think it's good to go for the next 2 years. I'm using Ford NEMA 17 for the Z-axis. Is that overkill or good enough? Well, depending on your motion system for Z, it's perfect, I guess. Like if you have one in each corner, you can do the quad gantry level, like the 2.4, for example. I was thinking about changing to CAN toolhead board. Yeah, I'm definitely gonna do that. I have all the parts already. I am gonna use, quickly grab that. Oh god. Wait for it. I will be using this one, which is the EVB 36 CAN. So that will be quite a nice package because everything is on there. And then I'm gonna I removed the expansion board. It comes with the LEO kit. I'm not sure if you remember, there's like a board on the below the motors, basically, or between the motors. I'm gonna remove that because at the moment this only like drives the toolhead board, which I no longer need. And then we discussed, I grabbed the power directly from the SKR Pico for the Pi. So the SKR Pico is going to power the Pi. And then somewhere right here, I have this CAN bus adapter that basically I'll put it then between the motors. And then, yeah, that will be complete set. Um, filament around LDs and other stuff. Yeah, like I'm not a huge fan of this like LDO toolhead board, like primarily because of the cable. Like the cable broke already once on me. But you also don't have really like a lot of extension or expansion possibilities on toolhead. Because there are no free headers. Um B36. Yes, I have the same one. You can find all the difficulties for me. I already have it like on on the poor man's Core XY, the custom printer I'm doing. We already run the exact board there. Exact same setup, like the same CAN bus adapter and the same EVB36. So that's all tested territory. You can check those streams if you want, but don't ask me when I installed it. At some point, we set up the toolhead board, and that's the EVB36 with that Physect CAN adapter, I think it is. I'm not using CAN bus with my printer for now. Are there any disadvantages for not using CAN? Well, more cables. That's the only thing, right? Like if you run CAN bus on your toolhead, you have power and ground, and you have a use like the CAN high, CAN low. That's exactly what you have. Like you have 4 cables. Whereas, I mean, you can see it here, right? If you don't run CAN on your toolhead, you need like a lot of different wires for all the different things on your toolhead. That's the only difference. It's like it's easier to manage. I would say it's cool. It's easier to manage. These are 2 things. Cool. But yeah, then I would call today. Thank you everyone for tuning in and enjoy your weekend. See you next week. Bye.